Okay, guys, once again, I welcome you to my lesson for today, where we'll be looking at this part of work, energy, and power. So, obviously, you have noticed that I've sent some information in the group. So, what I'm going to do quickly, is to go through the whole of this question. Most importantly, I'll firstly start with the given statement, read it through, and again do a bit of interpretation on the given diagram. And most importantly, ladies and gentlemen, as we always do, we go through the questions, all the questions in relation to the marks allocated to each question. So just make sure that you stay until the end of the lesson. And before I go deep, guys, please do allow me to say it's very much important that I say it's very, very much important, ladies and gentlemen, because what I'm about to say is massively important. Guys, a day without learning something new, it's a day wasted. By so saying, please do make sure that by the end of each and every lesson that I conduct, you learn some new. Guys, without any waste of time, I'm going to quickly read through the given statement. It reads as follows. So that was the original diagram that I drew by hand, that one over there. So the statement reads as follows. Just in case if you want to read what I'm reading, just click on back and then scroll up to that image. So before you even read the given statement, guys, they say for this question to start on a new page. Make sure to make to follow that instruction. Make sure that you start this question on a new page. I don't want a situation where I'm in the marking center and I'm trying to find the end of your question, and again I'm not able to tell which part is the start of your question. But when you start a new question on a new page, then it makes my life easy when I mark your paper. So good people, block P. So that means we are dealing with blocks, of which the first one is named block P, of mass 2 kg. Obviously, because it's a block, it has to have a mass. Very, very much important, ladies and gentlemen. So I've only spoken about block P, which has got a mass of 2 kg. So this block P, ladies and gentlemen, is connected to block Q. Okay, so that means we've got two blocks. And the second block is Q. And most importantly, they are saying these two blocks are connected. Okay, let's continue. So this block Q has got a mass of 3 kg. Very, very much important, ladies and gentlemen, that at all times you are able to read the statement. Can I ask Vier and Sazi to mute your mic? Vier, mute your mic. So these two blocks, guys, block P and block Q, are connected by a light inextensible string.
I can't hear you clearly because those people that are opening their mics.
Mute your mic.
There are people opening their mics.
Okay, let me mute it from my side, but he must be aware that he'll be banned on the next lesson. Okay, so ladies and gentlemen, what it means is that this string, which is connecting block P and block Q, we can ignore the mass of that string. It doesn't serve as a restriction, or otherwise it doesn't have any impact on either the movement of these two blocks or whatever, guys. Just know that the purpose of this string is just to connect these two blocks and it ends there. So Don't worry that much about that string. Just know that it connects block P and block Q. Very, very much important, guys. So both blocks are on a plane inclined at an angle of 30 degrees to the horizontal. So that statement alone, it tells you in terms of on which surface these two blocks are. That means these two blocks could possibly be on a horizontal surface which has got an angle of 0 degrees. Or otherwise, good people, it might be on an inclined surface at an angle of whatever angle. So normally that angle is less than 90 degrees. That's why it could be 17, it could be 25, it could be 30, it could be whatever. So you just need to be aware in terms of which angle is which, just in case you're given more than one angle. So the first 30-degree angle that we're given is for that surface there, is for that angle of inclination. Just be careful of that, guys. Don't confuse the given information. So can you see, I've actually done representing the first the first paragraph. Let's see, this is block P, this is 3 kg, this is block Q, and they said both are connected with a string of inextensible string. A light inextensible string. So let's continue, guys. Block Q is pulled by a constant force of 40 Newton at an angle of 25 degrees to the incline. Very, very much important, ladies. So that means this block Q is being pulled. In which direction? Guys, these are the type of questions that you should ask yourself in physical sciences. What represents the direction in this chapter, guys? It's an arrow. Very, very much important, ladies and gentlemen. Just check on that arrow, on that diagram, in which arrow, in which direction is the arrow pointing. So obviously you can see it's in that direction, which means this object is being pulled in that direction. Notice the difference between these two words, guys. If you have an object, let's say for example you have a object over there being object X, this object can either be pulled or pushed. So if it's being pulled in that direction, then we are going to have an arrow starting from this side of block X. Then you have a line with an arrow, it shows the direction. But if an object is being pushed, very, very much important, ladies and gentlemen, it's going to be an arrow pushing this side of block X. Just be careful of those words. It's fine for now, doesn't matter that much, but you just need to be aware that in this case we've got an object which is being pulled in that direction. So be careful, guys. Let's have a look at object Y. This is object Y. This object Y can either be pulled in that direction at an angle of 0 degrees, or otherwise at a certain angle in that direction. So just think of a card. Let's say we've got a card over there and you've got a very big donkey, guys. How am I going to draw a donkey over there? Let's say this is a donkey, guys. Yeah, this is a donkey, guys. A very beautiful donkey there. Yes. So can you guys see? In this case, obviously, let's say we connect a string there at that angle to the neck of that cut there. Can you see, guys? In this case, that's where if we had to represent this, we are going to have that cut over there. So the force, as you can see, that string, it's at a certain angle, ladies and gentlemen. It is at a certain angle in that direction because that's where that donkey is heading. So that is why in some instances you'll find that they say a force of whatever magnitude is being either pulling whatever the object in that direction at a certain angle, of which in this case it's at an angle of 25 degrees to the horizontal. There's nothing complicated here, guys. You just need to visualize all of these things by imagining some objects in your head. So it could be that this is cut A with A poles. Then from there, it's also connected to cut B, which has got some oranges in there. And both of these are connected with a string. But can you see, in this case, they are on a horizontal surface. Then after some time, there's a mountain. Then they have to climb a mountain, of which you are going to have those two cars at an angle connected. And then in that direction there. So they are moving, ladies and gentlemen, obviously in that direction. So can you see that angle of inclination there? It could be that one which is 30 degrees. So that is the reason why I'm saying, guys, try to visualize whatever that is drawn over there by dreaming about some situations. So I hope what I've explained up to this point, it makes sense. So let's now continue, guys. Let's see. The third paragraph says block P. Where is block P, guys? This is block P. So we've discussed about block Q with that angle having that force in that direction. But very, very much important, ladies and gentlemen, you can write down that force, the magnitude of that force, which is 40 Newton. Let's see. Block P is a block P moves on a rough section AB of the incline. So that means we've got a section, guys. As you can see on that same diagram, we've got section A, we've got a B, and we've got C. But in this case, they are saying block P moves on a rough section AB. So that is the reason why it is necessary for you to show something similar to that, so that you do not forget that section AB, it's actually rough. Remember, guys, I'm just trying to explain by being slow. But if I was in exam, guys, I'm sure I'll be doing question 7 now. So don't get to exam and try to visualize myself explaining and interpret this stuff at the same pace. Because I'm telling you guys, by the time you write question 2.4, that's when your invigilator will be saying 30 minutes left. So just make sure that when you get to this type of problems, you quickly analyze everything, quickly go through the questions before you can start with your first question. Make sure that you have read from the first until the last question, just so that you are aware in terms of the sequence in which questions are asked. Because most of you guys, you've got a tendency of answering question number 3 in question number 1, or question number 7 in question number 4. It normally happens in mathematics, where you answer question 5 in your question number 2 answer. Then when you get to question 5, you don't know exactly what you're supposed to calculate because you are scared of repeating the same calculation. So that is the reason why I'm saying when you are in exam, ladies and gentlemen, read through all the question. Do not just read through the question, but quickly read through the questions, just so that you understand the sequence of the questions. So guys, let's continue. They said block P moves on a rough section of AB on an incline, or of the incline, while block Q moves on a frictionless section of BC. Where's BC? BC starts from there up to there. So they are saying is frictionless. Let's see. Then they say see diagram below. So guys, what I did, it was more like I had to redraw all of this based on the given statement. Good people, why would I redraw all of these while it's drawn on the question paper? It's because sometimes you might be given additional information on the statement of which it's not appearing on the diagram. So it is very, very much important that at all times you read the given statement versus the given diagram. It helps you, good people. Sometimes examiner might try to be tricky and give you all of this, but do not, by means of that zigzag there, show that AB is actually rough. So you just need to be careful that if it's not what is it, zigzagized or whatever, you zigzagize it. Why? So that you never forget that section AB, it's actually a rough surface. So I'm just giving you an example that it's not at all the times where the given statement will match what is given on the diagram 100%. You might be given 80% information on the statement and the rest of it can be found on the diagram, or otherwise vice versa. Okay, someone joined and had their mics unmuted. But before I move to that paragraph, I think it's a quick one. Let me just quickly go through that one. So below that sketch, you can see, guys, they say an average constant frictional force of 2.5 Newton acts on block P as it moves from A to B up the incline. Very, very much important, ladies and gentlemen. So that means, can you now see the information that we read in that given statement? It did not talk about the amount of frictional force, and again, it is not shown there on that diagram. Most importantly, guys, a frictional force is always in the opposite direction of the motion. What does it mean? It means if an object is moving in that direction, the frictional force is going to be in the opposite direction. So because of that force which is pulling Q, it means this object is moving in that direction. If there was no force, probably these two objects were going to slide downwards. So you just need to be careful of in which direction is the system moving. So before you can say frictional force is there and again in that direction, ask yourself in which direction is that moving. So that means we have frictional force in that direction. What is the magnitude of that? Is 2.5 Newton. Very, very much important. So guys, before we start with the business of the day, which is going through the questions, are you all happy with what I've explained? By that I mean, did you all understand? And can we move on to the next section of our lesson for today?
Definitely, yes, sir.
Yes, sir.
Yes, sir.
Okay, 100%. So guys, let me just quickly make this announcement while you're still on the lesson. Can you see someone in the group is saying, say, I have a problem about chemistry, please, can you help me? I understand this is our new learner, but guys, just make sure that for this type of questions, you ask them via inbox, because if we have this group with lots of inboxes from other learners, we are going to miss, firstly, important information. And again, when we try to search for previous information, we won't be able to find it. So just make sure that as soon as you join my group, you click on the pinned message. It has all the information. So it's more like, guys, when you say you need assistance from me, do not tell me what you want. Just say, how do you operate? Then I'll explain how I operate, because the way you want things to be done for yourself, it might not suit everyone else. So what I do is to try and accommodate
No,
everyone. That
sir.
is
I
the
don't
reason
hear
why
anything.
everything is done in
I
the
don't hear
group
anything, sir.
all at once. So guys, let's now move to the business of the day. I'll just quickly check over there the first question. So the first question says, state Newton's second law in motion. So everyone who has been attending my lessons since the beginning of the year, they know very well that in physics, I ask a question regarding the cream of the question. So guys, for the new learners, I'm going to explain what is meant, or what do I mean by the cream of the question. So guys, the cream of the question is that weight, or those weights, when removed from a question, the whole of the question will remain senseless, or otherwise it won't make any sense. So the cream of the question is what wants you to answer. If the question says, how old are you? Do not say 20. 20 what? Let me see. How old are you? It ends with a question mark. And you say 20. So if you say 20 and I'm an examiner, we are marking your answer sheet. What is this, guys? Is this a temperature? Is this the velocity? Is this the mass? Guys, never, ever, ever, ever in physical sciences just write a number unless this is question number 20. Then we know this is question number 20. But what is the answer for question number 20? What do I mean by that? If the question says, how old are you? Answer, guys, to say I'm 20 years old. Then I know when I've got the memorandum, I don't have to get the question paper to see which question you were answering. With just that being the unit of that number, I know very well that the question was asking about your age. Then I'm going to give you a mark for the age and also for the unit. So, guys, be careful of that. So, in terms of the cream of the question, how old are you? So let me see. If I remove that weight, then I've got old are you. I can still assume that the question was actually asking how old are you. Then if I remove that weight old, then I remain with how are you. Can you guys see? This is now a complete new question which asks in terms of how are you. You can still respond to this question, but now if I remove that, it's how old you. I can still assume that the question says, how old are you? Then I can give my age. If I remove that, then it says how old are. I can still assume that the question actually wants to know my age. But the moment I remove these two words, then I remain with are you. So that are you alone, it's actually senseless to me. I cannot tell if you are asking how old are you or how are you. It could be anything else. So that means the cream of the question is those two words. Together with this, then it guides you in terms of how to answer your question. So someone who's been attending my lessons since the beginning of this year, I'm going to tell you they will answer this question. Guys, 2.1, it's allocated 2 marks. And the question says, state Newton's second law in weights. Good people, what is the cream of the question? Remember, unmute your mic, mention your name, make your point, mute your mic.
It's Newton's second law.
Make sure to speak a little bit louder. I think my volume is at maximum. Just make sure to put the mic a bit closer to your mouth so that we can hear what you say.
I think it's Newton's second law, sir.
So Minentle says Newton's second law. Someone else, what do you think is the cream of the question?
Teacher, Newton's second law in words.
So teacher says Newton's second law in weights. So both of you guys are correct, because without those weights, Newton's second law in weights, you wouldn't 100% answer the question. So I'll just give you an example, guys. So if you just say maybe Newton's, let's say, second law, if this thing alone, we consider this as the cream of the question, it's a bit risky in a sense that we don't know how they want us to state or otherwise to respond to that question. What if maybe we can represent or state Newton's law by means of a formula? So I'm just giving you an example, guys, to say Newton's second law in weights. It's very, very much important. That means you must state it in weights, guys. Do not draw your friend there and say this is Newton and draw some apples there and say Newton says this apple is falling, this thing is doing what. No, guys. State Newton's second law in weights. And what I like about physical sciences is that Newton's second law, it never changes. It's exactly the same. When you get to varsity, guys, the definition for Newton's second law is still the same. So that is why I encourage all of you guys to know these definitions by heart. Just make sure that when you go to exam, you know it by heart. The moment they say state it, quickly, you just give it to them. So one thing for sure, we are not going to waste any more of our time stating Newton's law. I'm 100% sure that everyone in this group knows how to state Newton's law. Otherwise, in case if you are not, just make sure to send me an inbox. I'll refer to you to a textbook that you can use to study and find all of this type of laws. Do you guys agree with me on that one? Can we skip that first question and assume that everyone knows how to respond to that question?
Yes, sir.
Yes, sir.
No problem.
Okay. Very, very much important, ladies and gentlemen. Let's now move to question number 2. And this question, it's allocated 4 marks. Good people, the question says draw a labeled free body diagram for block P. I'm telling you guys, if you attended a lesson that I did when I first started with this chapter, everything that we are doing here is going to make a perfect sense. Even if you did not attend, you will still be able to understand what I'm going to explain. But the difference is you won't be confident if you were given a similar type of a problem to solve on your own, because you don't have a background. That is the reason why for each and every chapter that I start with, I give you guys a bit of a background so that everything that we'll be discussing, whether solving question papers or whatever, will be referring to that background. It's unfortunate we have done that lesson already, but fortunately it has been recorded and it's posted on my website or YouTube channel. So there are those of you guys who don't prefer to catch up, and reason to that is probably because you can't ask questions. So that is the reason why I've got the one-on-one lessons where I can start again and re-explain what I explained and teach you from the start up until the end. Then you will be on the same page as everyone else, and most probably be on an advanced level, because I'll be doing it for the second time. I've already noticed what I couldn't explain on the previous lesson. So it's always advantageous to redo this type of questions. So here comes a question, guys. What is the cream of the question? In this case, the question says draw a labeled free body diagram for block P. And this question is allocated 4 marks. Good people, what is the cream of the question? Remember, mention your name. This time around, guys, let me do it differently. Just mention your name, then I will recognize you. Don't give an answer. Just mention your name if you want to give it a try, and then I'll recognize you. And remember, guys, you are not restricted from using your home language when communicating in these lessons. You are here on your own. You know the challenges that you're having. It remains my responsibility to make sure that I explain step by step and make sure that everyone understands. But when you want to ask your question, ask with the language that you are confident with, because when you ask a question, it's in most cases where you are asking for yourself and not for everyone else. So just make sure that in case if you've got a question, if you're somewhere in KZN or vendor, because I know there's someone who's in vendor who can translate in case if I'm not able to understand. Someone in KZN, ungabuza sizokusiza. I'm petting myself, I'm not sure how to say that in Tsonga, but let me not even give it a try. Good people, mention your name and I'll recognize you. Anyone who wants to give it a try, doesn't matter whether your response is correct or wrong.
Anita.
Lebohang, Anita. Who else wants to give it a try?
A labeled free body diagram.
Lebohang. Can you see, guys? So, it's very, 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 very much important that you listen to the question. And again, when the question is in a written form, make sure that you pay full attention to every detail. I said, mention your name and I will recognize you. Do not give an answer as yet. Guys, Anita, I'm not sure if you're the one who mentioned their name or you gave an answer. I just wanted a name, guys. But I noticed Anita also
No,
mentioned...
I just mentioned my name, sir.
Okay, you are recognized.
Teacher.
Honorable member, if you are recognized, it means you can hit the road. So, Anita, you are recognized. Tisha, noted. Anita, give it a try. Okay, Tisha, give it a try.
Free body, sir. Free body
Tisha
diagram.
says free body.
No, sir, it was Anita who said.
I think so.
Okay. Okay, Anita, noted. Free body. Tisha, what are you saying?
Labeled free body diagram of block P.
Labeled free body diagram of block P. So let me just leave it there. I'll come back to this part and comment on it. Let me see. Lerato, are you there? Can you tell us how can an examiner try to trick us with this type of questions, especially on this part of drawing this thing of a body diagram?
Sir, I can't hear you. I'm cutting.
Make sure to have your mic closer to your mouth.
Sir, you are cutting. I can't hear you.
It's unfortunate I can't hear Lerato. I'm not sure, but it's fine. I'll explain. So, guys, you have two things in this case. A free body diagram. And again, you've got a, what is it, guys? It's a force diagram. Am I correct?
Yes, sir.
Okay, so ladies and gentlemen, be careful of what is being asked. Examiner may say, draw a labeled free body diagram, or otherwise they may say a force diagram. Just be careful of the difference between the two. Just in case if you're not aware of those, make sure to catch up on those previous lessons because I explain in detail in terms of which one is which. So if they say free body diagram is different from force diagram, you represent them differently. If you just draw a free body diagram, you won't get maximum marks. So between these two, a good people free body diagram, it's something closer to the cream of the question. So these are the ingredients. So the cream of the question in this case is labeled free body diagram of block P. Very, very much important, ladies and gentlemen. We said when we draw either a free body diagram or a force diagram, we draw that on one object. So that is the reason why it is important to include that P as part of the cream of the question. Why is it necessary for you to identify the cream of the question? Is because in you answering the question, if you draw something similar to that on object number Q, and you show that, maybe you show that, and then from there you show that. The question is this a response to the cream of the question? It's a big no. Why? Because this looks like a force diagram. And secondly, this is not drawn on object P. Very, very much important, ladies and gentlemen. I hope that makes perfect sense to everyone. Most importantly, guys, this question is allocated 4 marks. What does it mean? I've always known when I was in high school that normally when it's given 4 marks, we are most likely to have 4 forces acting on that particular object. If it's given 3 marks, we are most likely to have 3 forces acting on that particular object. Very, very much important, ladies and gentlemen, that at all times you are aware of this type of information. Guys, how do we represent a free body diagram? Firstly, you do a dot. Very, very much important, ladies and gentlemen. After you have done a dot, the next thing that you do is to draw arrows which are pointing away from that dot. Massively important that you are aware of this type of information. Please, guys, do make sure that you catch up on those lessons. So I think I'm going to give you this weekend to catch up on the previous lessons. Possibly sometime next week, Monday, we might be starting a new chapter. And again, guys, I'm not sure of what will be our next lessons. It all depends on multiple multiple factors. So before I conduct any lesson, I check with my learners in terms of what is it that they've done at their school, what is it that they are busy with, what is it that they are struggling with, and then from there I decide on the next lesson. So in case if my next lesson is going to be, let's say, a circuits, and yourself you want, let's say, a VPM, just click on the pinned message to check if VPM, what is it, vertical projectile motion, is available in one-on-one. If it is, and you can't wait until we get to VPM, then you can request for one-on-one a lesson. But for general lessons, it depends on multiple factors. I'm just not sure of what will be our upcoming lessons. But one thing for sure, I'm sure of the lessons that we've already done, of which you can catch up using my website. Good people, let's now draw a labeled free body diagram. Why is it necessary to say a labeled? It's because after showing the arrows, you must also tell the type of that force. That is why we call it a labeled free body diagram. On which object? On object P. Massively important, guys. Obviously, we have that one as a result of that string. So obviously, the force that is there as a result of a string is what we call tension. Guys, if you do this, they are not going to give you full marks. Why? Because we don't know whether this tension is acting in that direction or that direction. But one thing for sure, arrows always on free body diagram, they point away from the arrow. Never ever see yourself doing something similar to this. Never, 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 never. It's more like this is a charge A, which is maybe either positively or negatively charged. So when we get to that chapter, you will understand better, guys. So just make sure that you are careful. So obviously, frictional force is acting in the opposite direction, that we know. But in most cases, guys, these arrows, they've got different lengths. So you might find that this one for frictional force is always the shortest. But most importantly, make sure to label it so that it's a labeled free body diagram. Massively important, ladies and gentlemen. So remember, guys, always, it doesn't matter whether an object is on a horizontal surface or on an inclined or on a very steep guys, always the weight or force of gravity, it's always downwards. It doesn't matter the angle of the slope, guys, whether it's on a horizontal at an angle or very steep, it's always downwards. Guys, why do I have to tell you all of that? It's because in this case, that block P, it's on an inclined, but what we know very well is that the weight or force of gravity, it's always downwards. So remember, the arrow is very, very much important. Someone is asking themselves, say, what if myself, I did force T? Guys, we are still going to give you a mark whether you say tension or FT. It doesn't matter whether you write that F or you say force, capital letter F, and that smaller than F over there. We are still going to give you a mark. So can you see, guys, we've got 3 forces. Marks allocated is 4 marks. Remember, guys, we say the normal force, it acts perpendicular to the surface. So where is the surface? There is the surface. So perpendicular, it's in that direction, which means we are going to have the normal force in that direction. Guys, it doesn't matter whether you write N, you can still write Fn. I'm telling you, I'm going to give you maximum marks. But remember, guys, when we perform calculations, I hope at this point in time you still remember that we've got what we call the components of forces, of which you will have a better understanding when we get to the calculations, if there are any calculations. But guys, I'm going to give you a mark for what? For the labeling and for the arrow or the correct direction in which the normal force is acting. Good people, I'm going to give you a second mark because of the arrow, the direction, and the labeling. Very, very much important, ladies and gentlemen. I'm going to give you a mark over there. Guys, I'm going to give you a mark for that one. If I find your drawing funny, or it looks like it's a bit drunk, it doesn't know where is home, where is the gate to enter the home, I'm going to give you some halves somewhere, guys. I'm going to be giving you some halves. If that force of yours, it looks like is that horizontal one, I might not even give you a mark because it seems like you were dodging my lessons. I will never, ever, ever, ever give you a mark for that because it tells you were not attending my lessons. Good people, before we move to the next question, are you all happy with what I've explained up to this point?
Yes,
No. Yes.
it's all understandable.
Guys, I'm just not sure if it's the mic, if it's my phone or what. Let me just check if the audio NYC, it's not on loudspeaker. I just made it on loudspeaker because I couldn't hear a thing. Guys, did you say you are happy with all that I've explained up to this point?
Yes.
I'm
Okay,
happy.
100%.
Yes,
Quickly, let's try to draw a free body diagram on that 3 kg. Listen to my question, guys. A free body diagram. So that means I'm going to have a dot over there. So after having a dot, I know in that case, I've got a force in that direction. And that force is that which I can refer to as an applied force. Force. And again, always for an object that has got a mass, it has a weight or a force of gravity. Guys, you know a feather, most. You know a feather. Let me just try to draw a feather, guys. You know a feather on its own, it can just be floating on air. It can just be floating on air. And the reason why it is able to float on air is because, remember, Fg, for an object to have a force of or experience force of gravity, it must be represented by that formula. So we know whether you are sleeping or whether you are awake, whether it's your birthday or otherwise, whether you are writing exams, G will always be 9.8. But what about this feather which is just floating? Does it mean there's no G or what's going on, guys? So it could be because the mass of this feather is negligible. What does it mean when we say it's negligible? It's more like it's massless. That is why it is able to, on its own, just float. So that means the mass is possibly 0. And if the mass is 0 multiplied by 9.8, then it means the weight of this, remember the weight and Fg is the same thing. Then it means the weight is 0. So it's more like a feather. It doesn't have a weight. That's why it can just pack itself on top of your head and you won't even feel it because it's not heavy, it's weightless. So that means for an object that has got a certain mass, it will therefore have a weight. That is why that 3 kg and that 2 kg will always have force of gravity or the weight. Very, very much important, ladies and gentlemen. Remember, guys, for as long as this object is sitting on a surface, it is always going to have a normal force perpendicular to that surface. That is the reason why when we look at, let's say, a tennis ball, which is maybe falling from the top, we just have force of gravity, or otherwise we just have weight. There is no normal force. Why? It's because this object is not sitting on a surface which could be horizontal or otherwise on an incline. So we just have to wait for it to hit the ground. The moment it hits the ground and it maybe lies there, that's when we know we are going to have normal force as a result of that surface. And again, if this object is not experiencing any other external forces, then it means we do not have frictional force. So therefore, the only force acting on that ball is the frictional force. That is what we call a projectile. A projectile, ladies and gentlemen, let me not go deep, because if I go deep, I'm going to start a new chapter. But what I wanted to explain to you guys is that for that 3 kg object, it seems like we only have these 3 forces. Why are they 3 and there we've got 4? It's because section BC is frictionless. Therefore, there is no frictional force. Good people, why is it necessary for you to secretly or aside draw a free body diagram for object Q? It's because when you when you do calculations, you might need both of these. Guys, I'm not sure if you are able to notice something that I forgot over there. Is there someone who wants to ask a question or maybe tell me exactly what I forgot? Because I see there's someone who's asking themselves a question. This is the
I
opportunity.
think it's tension, sir. I think it's tension. I'm not
100%.
sure.
100%. So can you see, guys, sometimes during my lessons, at some point you'll be wondering how. What about that tension over there? Then you keep quiet. Good people, do not keep quiet. Make sure that you unmute your mic immediately when you notice that there's something that is missing. And the reason to that is because sometimes I deliberately leave out that information just to check if indeed we are still on the same page. Because as it stands at this point in time, I'm not really sure how many of you are attending this lesson. I'm not sure if I'm speaking alone. But if I am, I know there's no one who's going to be laughing at me to say, you are talking to yourself. But if there's someone watching, I know whoever who's watching, then this lesson is presented to them. But now, if you notice there's something wrong and you keep quiet, then I'm just not sure if I'm still alone or we are still together. But one thing for sure, guys, I'm telling you, even in real life, when you notice there's something wrong, make sure to speak up immediately. Because whatever that comes to your mind, it is influenced by something. Like in this case, she noticed that we've got that tension there. So possibly it could be a force which should be indicated on this drawing. So that means that tension, it has to have an arrow, which means the tension on object Q is in that direction. But notice something, guys. Can you see? The tension on P is in that direction. So that means that stream, which is that one, it has an arrow in that direction and again in that direction. Why is it the case? It's more like this 3 kg, it's actually pulling this block P. And at the same time, it's more like this block P is pulling that 3 kg. That is what we call a tension. So a tension, that's where we've got a string and the other one, it says I'm pulling you towards myself. And the other one is saying, no, I'm also pulling you to myself. So this type of a force where you've got that, we call it tension. So the type of a force which could be in that direction, when you get to varsity, you will notice the difference that in a string, you can either have tension or compression. But let me not go deep into that because we are only focusing on high school stuff. Guys, I want to tell you something. I've never said this on my YouTube channel or in any of my lessons, but I think it's worth mentioning. And again, I'm going to create a very special video where I take you guys through the tips on how to get distinctions, on how to prepare, on how to. It's going to be all about how to. Just make sure that once that video is out, you check it out. But what I want to tell you guys is that myself, I studied civil engineering at UJ in DFC, Doornfontein. So someone in this group wants to study mechanical engineering. So if you want to study mechanical engineering, let's say during your first year, the costs of your course, let's say, okay, let me just keep it simple and say it's 100,000 for your first year. Good people, if you pass with good marks, for example, you get distinctions, as many distinctions, if you can get as many distinctions as you can, there's what we call merit bursary. So merit bursary, guys, it's a bursary that you are given by the institution. If you'll be studying at VETS, so that means VETS is going to give you a bursary, and that bursary is calculated on your score. So that means, let's say you get maybe a level 7 physics, level 7 mathematics, level 7 life sciences, level 7 geography. By the way, I got distinctions in all of these, guys. So I do have the capacity to teach life sciences and geography. It's just that I haven't got a chance, but I think I'm going to create a separate group where those who are interested in those subjects, they'll then join that group, especially map work. I know most of you struggle with map work. Let's say maybe we get 6 in other whatever and 6 and maybe 6. So what is the total of that, guys? Let me quickly check. It's 14 times 2 plus 6 plus 6 plus 6. You get 46. Let's say your score is 46, guys. So, and maybe that 46, it qualifies you 80%. So that means on your first year at VETS, VETS University is going to sponsor 80% of your fees, which means you are only going to pay 20%. I think it should be, 20,000 of 100,000. Guys, something very interesting, which also, which is something that I've experienced. Because you passed very well with distinctions, you have high chances of getting a bursary, an external bursary. So that bursary says we are going to cover 100% of your fees. So you got a bursary from Anglo-American or whatever, then they pay university that 100,000. Good people, you still have merit bursary, which means the university owes you 80% being 80,000. So that means you have a choice to chow nicely that 80,000. Imagine yourself, guys, as tiny as you are, as a first year at TUT, you passed with distinctions, you've got a bursary, TUT gives you merit bursary, and the total cost of your fees at first year, it's 100,000. So the bursary is going to pay 100,000. Then it means, I might not have done some correct calculations there, but if the bursary pays that amount, and as a result of your score, you qualified for 80% merit bursary, then it means in your bank, guys, that amount of money is going to click because you can go and claim it from the institution. But this is how a very intelligent student will do, or a wise a student will do. They will not chow that money, guys. They will not buy some weaves, buy some iPhones, buy some whatever sneakers, hammer some Hubley then, what. They are going to reserve or save all of this money just in case if you fail somewhere in the middle of the year or on upcoming years and you lose the bursary from whatever, then you can use this money to further your studies. So guys, do you think all that I've explained just now, was it worth it, or did it waste part of our lesson for today?
Oh, it was actually helpful, and we didn't know about that.
Which means, good people, make sure to study even hard. Do not ignore this type of lessons that I conduct. It doesn't matter whether it's a grade 10 or grade 11 lesson, whether you're in grade 12, 11, or you're grading. If I'm doing a grade 10 lesson, if I mentioned in the group to say the lesson is dedicated to grade 10, 11, and 12, make sure to attend, because in each and every lesson that I conduct, you will definitely learn something new. And the main aim is to make sure that you nail those final exams to improve your marks, which puts you in a better position to either qualify for a merit bursary or otherwise an external bursary. So guys, let's now try to continue. And what I like about this group is because there's someone who might be in grade 10, and I know, for example, Tisha is in grade 12 and she wants to study, let's say, chemical engineering somewhere at UJ, for example. Then for those who are in grade 10 and 11, if I know the following year you want to study the same course that teacher is studying, I can still connect you with a teacher, because you wouldn't be a stranger to teacher, because you were taught by the same tutor, and again you were in the same group. So teacher can easily take you through orientation to say, this is our campus, this is where you attend lessons, this is where you can apply for bursaries, this is where you get a 1, 2, 3. So that is the advantage of having this group, and again engaging, because in that way we will never be lost after matric. So we just form a community of academics. So also Lerato applies for NSFAS, and you just finished your matric, you don't have bursary, don't know how to apply for NSFAS. Because I'm too busy, guys, myself, I'm too busy. I want to be honest with you. It's either I'm at work doing engineering stuff, or otherwise when I'm done I'll be preparing for your lessons. So I can just connect you with Lerato to help you in terms of how to apply for NSFAS or whatever the case may be, guys. So just make sure that you are known by myself, so that in case if you need a similar assistant, I can connect you with my previous my lessons from last year. I mean, my learners from last year. So guys, quickly, let's move to the next question. But most importantly, make sure you have this on whatever you're writing your notes, because we might need both of these, even though the question asked us to provide that one. But this one on the side, you might also need to have it. So let's quickly move to the next question. So let's see. 2.3 says calculate the magnitude of the acceleration of block P while block P is moving on section AB. Very, very much important. Guys, what is the cream of the question? Just mention your name, honorable member. I will recognize you. Guys, are you still there? If you want to give it a try, just mention your name and I will recognize you. Just in case if you don't have an idea of what is the cream of the question, you can just mention your name and say no idea, just so that I know got my question.
Hear the question.
Moleboheng.
What are you asking?
So, guys, the question is that image in the group. So, you don't necessarily need to rely on me reading the question. I think on your screen, somewhere you can click on back. It should take you back to the group. Then you can scroll up to find the question paper. Then when I start with calculations, you can then bring back the screen. So, Moleboheng, you are recognized. So quickly, the question said calculate the magnitude of the acceleration of block P while block P is moving on section AB. Moleboheng, you are recognized, honorable member.
Minentle.
The magnitude
Of the question.
Let's first start with a question. I'm not sure, is it Minentle's got a question before Moleboheng proceed?
Oh, so I don't have a question. I want to ngifuna respond to the question akayibuzile ukuthi iyiphi cream.
Okay, EP cream. Moleboheng, I know you might need it, but let's try someone new. Minentle EP cream.
It's a magnitude of the acceleration of block P.
Okay. Noted. Moleboheng, you are recognized. You can also give it a try.
The magnitude of the acceleration of block P.
Okay. Let's consider that to be the cream of the question, even though we can still add onto that. So some cream of the questions, guys, they are specific. So you also need to have the cream of the question in a specified manner. For example, if maybe you say the magnitude of the acceleration, both of these objects are accelerating. And again, they are moving through different phases, which means it is necessary for you to say, if you are saying the cream of the question is the is that magnitude of the acceleration, you already know that your final answer should be in meters per second squared. Do not perform any calculations where you give me something which is finally in kilograms. Ladies and gentlemen, do not give me your final answer which is something in meters per second. Good people, never ever ever give me your final answer which is something as time being measured in seconds. Give me the acceleration which is in meters per square second. But most importantly, not just an acceleration, but an acceleration of block P. Very, very much important, ladies and gentlemen. We've got two objects over there. So I don't have to ask myself whether this acceleration that you say is the cream of the question. I don't have to ask myself whether is the acceleration for block P or block Q or for both. And again, most importantly, it's an acceleration of which object moving on which section. So that means the cream of the question is the magnitude of the acceleration of block P while moving on block A, B. So, from what you're saying, guys, it's more like that part of moving on section AB does not form part of your final answer, of which it does in a sense that finally, you should be saying acceleration is equals to whatever. And we know that that acceleration is specifically for object P passing through section AB. I'm not sure if it makes sense to everyone, guys. Guys, did that make sense to everyone? Okay, I'm going to just make an assumption that it did make sense to everyone. So, guys, just help me here. Just make sure that everything that I'm doing over there is correct. So, one thing that I want to tell you guys is that the moment you start with calculations, especially on work, energy, and power, where you might find yourself having to use that formula of Fnet is equals to MA. Why am I saying this formula? Is because you know very well that this is where you are going to find your acceleration from this formula. So just make sure that you remember your the free body diagram for each object. That is the reason why I'm drawing all of that. So let's see, let's consider that as force of an applied force. Then what else do we have, guys? We have tension, and again, what else do we have? We have force of gravity, and again, we have normal force. So just make sure at all times to have all of that information, guys. So let's see. I just want to ask you guys a few questions. So that tension experienced by block P, is it the same tension which is that one experienced by block Q? Based on what we did on our previous lessons, those tensions, are they the same?
No, so for block P, tension is positive, and for block Q, tension is negative.
Lebogang says for block P, the tension is positive, and for block Q, the tension is negative, and therefore the magnitudes are not the same. Okay, point noted. The next one, what do you think, guys? Okay, it's fine. Molebogeng, thanks very, very, very much, because um, your point of view is going to enlighten most of our friends in this lesson. Guys, in physical sciences, when you have negative 20, for example, Newton, and again you have positive 20, let me even remove this n over there and say between these two numbers, which one is big and which one is small?
I think so they are equally, just it's acting in an opposite directions.
Lerato noted. But here comes a question, guys. Between this number and that number, which one is big and which one is small?
Positive 20 is
Pos-
blue, negative 20 is blue.
100%. So mathematically, we know that negative 20 is small, 20 is big. But because now we are doing physical sciences, it's not just 20. If it's a force, then we say 20 Newton, and then that one is going to be 20 Newton. So in physical sciences, it doesn't mean this one it's a smaller force because it's negative, and this one it's a bigger force. Good people in physical sciences, the sign represents direction. And this is what we call the magnitude. It therefore represents the size of the force. So this positive, it does not mean this force is bigger than that one because that one is negative. This one simply talks about direction, and this is what we call the magnitude, which refers to the size or the value. I hope that makes a perfect sense to everyone. So that means the tension experienced by P is the same, exactly the same as the tension experienced by object Q. So I'm going to try to do something, guys, and assume that this part is object Q and this part is object T, and they are connected by that string. So if I'm pulling this Q and I'm also pulling this T, the same pain is experienced by this and that. It doesn't matter whether this one is pulling stronger or this one maybe is pulling stronger. What you need to know is that both of this side of my fist and both of this side of my fist, they are experiencing the same amount of pain. The only difference is that if this is moving in that direction, then it means this is exerting or pulling at a certain amount of force, but in this direction. So even though this one is being pulled, it doesn't mean this side of my hand is experiencing a more pain and this side is not experiencing the same amount of pain, maybe because it's the winning force. Guys, I hope that makes sense. So that means I'm just going to write it in red to say the tension for object P is the same as the tension for object Q, is the same amount of force. It's only that they are acting in opposite directions, as Lerato has said. But remember, in this case, the question wants you guys to calculate the magnitude of the acceleration for object, P, as it moves through that rough surface. So let's try to formulate, guys. We know very well that the acceleration is actually going to come from this formula of Fnet, which is equals to ma. So what does Fnet mean? Fnet means total forces acting on a particular object. So in this case, let's start with object P and formulate. So because of force of gravity on this object, which is on an inclined, that's where we have those components of forces, guys. I hope you remember very well that here we've got force of gravity. What did we say, guys? I think we said this one is perpendicular because it's perpendicular to the surface. And we therefore have another one which is in that direction, and we called that one force of gravity parallel. So let's see, guys, between these two, we know very well that this one is being cancelled by the normal force. That is the reason why when we formulate, we no longer concentrate on that one and also that one, because it's the same magnitude but in opposite direction. If it's 20, it's going to be 20 positive and 20 negative. They will cancel each other out. Then this one of force of gravity, we do not include it in the calculations because we only focus on its components. So on the formula, that one, it falls out. Why? Because we concentrate on the two components of that one force, which means horizontally, possibly we've got a certain number of forces. And how many are those? It seems to be 1, 2, 3 forces. So that is the reason why you are going to say, in brackets, guys, in brackets, you have that force of tension in that direction, which is positive T. But before you even continue, guys, just make sure you indicate to say in that direction, or maybe to the right, assume it to be positive, then in that direction or towards the left being negative. So that means all the forces in those arrows, they will be positive, and in these arrows, they are going to be negative. So why did I have to put this in brackets? It's because that word net, it means you must add. What are you adding? You add all the forces acting on that object. Which object? That object P. That object P. That is what we're concentrating on. How do you know which forces are acting there? It's because of that free body diagram. So you need to catch up on my previous lesson to notice that you've got force of gravity parallel and force of gravity perpendicular. The reason why most of you fail when it comes to this part is because you don't understand how to resolve those components. So now let's see, guys, what other force do we have? Obviously, we've got force of friction. I hope you know very well that you've got force of friction in the opposite direction. Guys, why do I put in brackets? It's because I want to add to say we are actually showing the net or the total forces acting on that particular object. So what is the other force, guys? Is that force which is force of gravity parallel. And we said force of gravity parallel, guys, is force of gravity parallel. This is that one which is sine angle. Why? Because it's a component, not perpendicular but parallel, because it's a component of force of gravity. I'm not sure if you guys remember. Therefore, the whole of that, it's being equated to ma. Guys, did all of this make sense to everyone, or are you guys surprised? Are you wondering what exactly am I doing over there?
It makes sense, sir.
100%. So I'm telling you guys, only if you can be able to formulate correctly, you will never go wrong. So remember, guys, we said that tension is the same. So let me just write it in red. My red marker has turned into black. I don't know why. Let's see. So we've got a tension there. Is that a question?
Yes, sir, I have a question.
Okay.
So, sir, in a system, tension is always the same.
So yes. So the tension is the same for each of these objects. So that means that tension for block P is the same tension for block Q. The only difference is that they are acting in opposite direction, as you said. Does it make sense to everyone? So that is the reason why I was saying when I've got this and I'm pulling, in between these two fingers, there's a tension if I'm pulling in whichever direction. So tension is the pain that I'm feeling. So the pain that I'm feeling on this side is going to be the same that I'm feeling on this side as a result of the tension between these two objects. So it doesn't matter whether this object is being pulled in that direction or this direction, but because they are connected by a string, it means when you draw a free body diagram for this object and again for this object, that tension is the same. The only difference is that it's acting in opposite directions. Does it make sense, guys?
Yes, sir, it now makes sense because I also didn't understand.
100%. So, guys, can you see that it helps if you have a question when you are unsure of something? Because it helps me to expand my explanation so that you've got a better understanding. So, I hope we can now continue, guys. So, obviously, when you remove the brackets there, you are going to have negative force of friction. I'm not sure if we are given that force of friction, but if I remember very well, guys, they said we've got force of friction obviously in that direction. Am I correct in saying it was given as 2.5 Newton? Do you guys still remember?
Yes, sir.
Okay, then let's substitute, guys. Force of friction is that. Then that part over there, we know it is therefore going to be minus. So I know Tisha was probably going to skip this step and get to that shortcut. But otherwise, remember, guys, the aim is just to do each and every step, just so that even when you are studying alone and you notice the memo is a bit tricky, or otherwise it seems like it's a shortcut, you will know where that shortcut is coming from. So what is FG? We know FG, guys, is equals to mg. So that means we have mg sine angle. What is m? M is mass. Which mass? The mass of object P. So we are only concentrating on object P. So gravity we know is 9.8. Then you say sine. What is the angle? There is the angle, guys. So that is where you put in 30 there. Then you equate these two. What is the mass? The mass is 2, and there you've got acceleration, which is what you're looking for. So can we try to simplify this thing, guys? So I think we are going to have t. Can someone just punch all of this? Let me also punch from my side. You punch negative 2.5 minus into 2 into 9.8. Then you say sine 30 degrees, it's equals to, I'm getting a fraction button, but in a decimal form, this thing is the same as negative 12,3. This is equals to acceleration. So can you see, I've got two unknowns, and the first unknown is that tension and that. So this is where you consider this to be your equation number 1. Then you are going to derive equation number 2 on that object, and then you are going to make t the subject of the formula, then equate the two. Why? Because you know t is the same. So that means before we even conclude to make this equation number 1, let's somewhere just make t the subject of the formula. So that means t will be equals to 2a, then you transpose, it changes the sign, it becomes a plus 12,3. Then we consider this to be equation number 1. Guys, are you all happy with that calculation over there? Did it make sense to everyone?
It's clear.
Yes, sir.
Okay, in that case, let's therefore formulate for object, what is it, for object Q. So you need to remember that free body diagram. I hope you are able to see that free body diagram. So let's see, guys. Obviously, we know that Fnet, it's equals to MA. Which MA? M for Q, acceleration for Q. So what are the forces acting on that object? We know the first one, what is it, guys? Is it not tension, but in the opposite direction? I'm just not sure if you are aware of that, but I think we do have that tension, but in the opposite direction. Just make sure that that part, it makes sense. Let me also try to redraw that and say, can you see? The arrow is in that direction, and we assumed this direction to be negative. This is tension. We also have that applied force at an angle which is a certain angle. And again, we've got force of gravity. Remember, we also have normal force. So always force of gravity, when you have an object on an incline, you have to work out the components of that. So these are the components. So that means here we are going to have force of gravity perpendicular, which is going to cancel out with the normal force. So there you've got force of gravity parallel, and you know very well this is that one that has sine angle. So can you see, guys, this one also, it's acting at an angle. So you need to resolve that angle and have a, what is it, the component of that a force of A parallel to the surface. And remember, there you are given that angle being a 25. So can you see how tricky this one could be, guys? So remember, obviously, because you have a right angle triangle there, it means the force of the applied force horizontal, it is this one which is going to have cos angle, because it's on the adjacent side of that angle. So that means the vertical force is the one which is going to be a force of applied perpendicular, which is going to have sine angle, because it's acting in the perpendicular or in the opposite side of that angle. And also that force, it is also balanced with that force of gravity. So you just need to be aware that in this case you only concentrate on the horizontal forces, forces which are parallel to the surface. The vertical forces are cancelled, or they cancel each other out. Which means, guys, based on what I've explained, let me just try to formulate without having to remove all of. We have tension in that direction. What other force do we have? You can see we still have this one in that direction. So we can say plus, then we have mg. This is the one with a sine angle. Then you close a bracket over there. And again, do we not have any other force, guys? We do have that applied force. So that is why I'm going to say a plus, then include that force as part of the equation. So that means I'm going to have what is it? A force applied, and again cos of angle. So that angle, I'm not going to use theta because I used theta there. So I can use it as alpha. Why? Because if I say is angle theta, it's more like is the same angle to substitute there, whereas it's not the same angle. Guys, do you notice a mistake, or is everything correct? Guys, are you still there, or am I alone here? Let me check. Honorable members, are you still there?
Yes, sir.
Okay, here's the mistake, guys. There, it is not supposed to be a positive. Why? It's because this force is acting in that direction, and we assumed everything to be acting in that direction to be negative. So I hope that makes a perfect sense, guys. So let's now substitute where we can. We know there we've got negative t, and again we have minus, what is the m? we are now on object Q, which has got 3 kg. Then we have that sine. The angle in this case is that one of 30 degrees. Then we have a plus. What is the force of applied, guys? I think it's given as a 40, and again it's at an angle of cos 25 degrees. This is equals to, the mass is 3, and then there we've got acceleration. So let's see. Let's calculate what we can calculate. So we punch all of that on a calculator. Let's see. We have negative 3 times 9.8 times sine 30 degrees plus 40 cos of 25. Let me just make sure I've got 40 there. It's equals to, I'm not sure if you guys are getting the same answer, but I'm getting, we have negative t there. An answer that I'm getting, it's a positive answer, which is 21.55, let's say 23. This is going to be equals to 3a. Remember, guys, I'm writing it to 4 decimal places because it's not the final answer. So it's only the final answer that I'm going to round it off to 2 decimal places. So remember, guys, we said we wanted to make t the subject of the formula. So what can you do, guys? You can transpose this t to that side and move this one to this side. So that means you are going to have, let's say, 21.5523 minus 3a being equals to t. Then you can consider this to be equation number 2. Guys, are you still there? Am I not losing you guys? Let me see who's on the line. Just want to make sure that you guys, let me see. Lebogang, Renailo Lubisi, Grace Makito, Nontombi, Ntili, Apele, Olai, Katu, Korombi, Minentle, Rato, Tabzo T-Men. Are you guys still there? Am I not
Yes,
losing you
sir.
guys?
No, we're actually listening. Still listening.
Oh, okay. Because I know you guys are very fast, so my message takes forever, and I know sometimes there are some roadblocks and whatever. But remember, guys, can you see Lerato? Oh, I wanted to say Moleboheng. Can you see this T? We said is the same. So at this point in time, remember, you worked it out to make that t the subject of the formula. So if this t is the same, and remember, this is the t for what? For object P, and this is the t for object Q. So that means if t of object P is equals to t of object Q, then it means you can equate these equations because they are the same, or this t is equals to that for object P, and t for object Q is equals to that. You can therefore say equation number 1 is equals to equation number 2. So let's see, what is equation number 1? Is 2a plus 12,3 being equals to 21,5523 minus 3a. Therefore, you can solve for a. Let's see, we can transpose, then it becomes 2a plus 3a being equals to 21,5523. We minus that being 12,3. So that means 5a is going to be equals to, what are we having there, guys? is it 33? Just make sure if I'm correct. Is it 33,853? Let me see. Can someone just confirm for me if that calculation is correct over there? Let me just quickly check, guys. So what is it? 25,523 minus 12,3. Oh, no. It's a minus. No. No. It's a minus, so I actually added. So this is actually 9,253. So what I'm actually calculating is A. Then I'm going to divide by 5. So that 5 is going to cancel with that 5. Then I've got my A, which is equals to, so is that divided by 5. And I'm getting 1,8. Then I can round it off to 2 decimal places and write the correct units as meters per square seconds. And because I got a positive answer, it means this object is actually accelerating up the slope. So it seems as if the acceleration or maybe this acceleration is not necessarily for the 2 kg, but is for the whole system, because everything moves as a whole and it accelerates in the same acceleration. So even though they specify to say acceleration of the 2 kg when it moves from A to B, the acceleration is going to be the same until maybe it now starts moving on a frictionless surface. That's when maybe an acceleration is going to be different. So guys, I'm not sure if you are happy with this calculation, and we can move to the last part of the question, unless if there's someone who's got a question. But otherwise, if you don't have a question, remember this lesson is being recorded and I'm going to post it sometime during next week and share the link once it's posted on my website. Guys, are you all happy with this calculation, which is worth 8 marks?
We are happy. I'm actually happy because I also did the same calculations as you.
And you got the same answer, isn't it?
Yes, I got 1,85 meters per second squared.
100%. So that means we can now move to the last part of the question. So can you see, guys, during the beginning of this lesson, I think we started some like 16 or 16 members, 17 or whatever, but the number towards the end of the lesson, it gets reduced. So next time when we'll be doing a similar problem, someone is going to be asking a question of which I explained in this lesson. So it's unfortunate. I will respond to their questions, but I'm going to be quick, guys. I won't bother to go into detail because it doesn't help to be explaining one and the same thing over and over again, especially when the explanation is there online. It's posted online. So just make sure that if you can, you stay until the end of the lesson. The lesson. Sometimes, for some reason, you are not able to, but if you are not able to, make sure to catch up when the lesson is posted. So if for some reason you are watching my previous lessons and you don't understand something, there, I'm telling you guys, you are more than welcome to ask me any question, because you'll be asking me on something that I've already done. Unlike those new students who just send me their homeworks, their handwritten problems, their assignments, asking me questions. And it seems like I don't want to be helping those learners, of which I do want to help, guys, but there's a way in which I operate, a way which suits my schedule, and again it suits everyone. That's why I do one lesson for everyone at once, but only if you catch up on previous lessons and you've got a question, you can definitely ask me. I will easily explain by sending you a voice note. As long as you can say, I'm watching this video, you send me the link and you say, fast forward to 17 minutes 50 seconds, then I'll fast forward, then you ask your question via voice note, then I'm going to fast forward, listen to what I was saying, then from there I'm going to respond with a voice note. So that is the best way in which I can help you. But if you've got an assignment, a homework or whatever, I don't help with those, because I'm going to make you get 100%. Your teacher is going to think you understand, you know these things. They won't teach you some more. Come exam, you will be hammered and you are going to regret, but you won't notice that you are getting hammered because I helped you to get 100%. So don't be happy to get 100% in classworks, homeworks, exams, or whatever. Make sure that you gather as much information as you can in preparation for your final exams, because your report or your final statement in matric, it will be based on your final exam paper. So it helps in case if you've got that teacher who hates you that much. Don't worry about that teacher. Just make sure that you gather as much information as you can, knowingly that your final answer or your final answer sheet will be marked by someone in the marking center who doesn't even know you. But because you write neatly, you start each question on a new page, you only round off your final answer to 2 decimal places unless specified, and you show all the steps. In physics, your directions and everything, they are clear, the angles, you write the correct SI unit with the direction for vector quantities. Good people, I'm telling you, you will get 120% with physical sciences. And guess what? You will qualify for that merit bursary. Good people, you will be given a lot of money. And that money, it's up to you whether to hammer yourself with some long nails there, or some sneakers for some gents there with some nice cap and a necklace and whatever. Otherwise, you can just spade aside. Make sure that you use it during heavy rainy seasons. So, good people, I hope you are now ready for the last question. It's a very quick question which is allocated 2 marks. And the question says, if block P, so let me just bring that diagram, and it says if block P has now passed point B, how will the acceleration compare to that calculated in the previous question? Choose greater than, smaller than, or equals to. Obviously, you know and understand what is meant by the cream of the question. So now, just make sure to mention your name. I'll give you an opportunity to give it a try. Remember, guys, whether the answer is wrong or correct, it is advantageous to me and yourself. So, guys, mention your name and I'll recognize you. Remember, guys, if you've got no idea, just mention the same whoever, no idea, just so that I know you received the question and we are not both waiting for each other. Okay. I'll just make an assumption that was there someone who wanted to give it a try? Because I know it could be that the message is still sending. But guys, is there someone who wanted to give it a try? Okay, it's fine because I notice maybe my message is taking forever. So, guys, in this case, what happens is that obviously this object is moving on a rough surface. The moment it passes that rough surface, then it means there is less of friction. Therefore, the acceleration will be greater than. So in answering that question, you will say a greater than. And the reason to that, it's simple, guys. Exactly what you're seeing there. It's because between that section BC, there is no friction, first and first. Or otherwise, the force net increase. Remember, this is the formula for S net, which is equals to MA. How does the force net increase? It increased because previously acceleration was 1.85, but because now it's moving through a frictionless surface, acceleration is going to increase. So when it increases, it means you multiply the mass times increased acceleration, which is going to increase the force net. So you can either say the force net will increase, or you can say there is no force of friction. So obviously, if there's no force of friction, someone can say the surface is smooth. So for you to say greater than, we give you a mark. For you to give you any of those three reasons, we give you 1 mark. So guys, this brings us to the end of our lesson for today. Just want to have an indication from your side if you guys were happy with today's possibly last lesson on work, energy, and power.
Yes, I was happy personally. I felt like I had misunderstandings as I was doing the activity, but because you explained, everything makes clear now.
I was also so happy.
Yes, I understand everything.
Yes, you brought clarity to what I had misunderstandings on.
Guys, I'm just not sure of what happened there, but I was saying I hope everyone did enjoy the lesson for today as much as I did. So, good people, have a good night. My name is Desmond, and I'm out.